and specifically we're going to look at the history of the subatomic particles. And our learning intentions for today are to briefly outline the historical development of atomic theory, referring to the scientists Dalton, Crookes, Stoney, Thomson, Millikan, Rutherford and Chadwick, and we're going to list the properties of electrons, protons and neutrons. So before we start to go into the history of the atom, we need to look at a few definitions. So the first thing we want to look at is we want to see what matter is. And matter is anything that occupies space and has mass. And matter can be composed of different particles, and these particles are atoms, molecules, or ions. So, if we look at molecules and ions to start with, molecules form when atoms join together in groups. And an example of a molecule is a very common one, which is water. So water has 2 hydrogen atoms and 1 oxygen atom. And that's written as H2O. Ions are particles that have electric charge. So an example of some common ions would be the chloride ion, the bromide ion, etc. Now if we look at atoms, first of all the word atom comes from the Greek word meaning unsplittable. So atoms are indivisible. Elements consist of only one type of atom. So the element carbon will only have carbon atoms. The element oxygen will only have oxygen atoms, etc. Atoms consist of subatomic particles, and there's over 70 of them. However, we're only going to focus on the 3 main ones on the Leaving-Cert course, which are electrons, protons, and neutrons. So when we're looking at the history of the atom, there's 6 important scientists to know about. And these are Dalton, Crookes, who's associated with cathode rays or the electron, Thomson, who's also associated with the electron and some part of the structure of the atom called the plum pudding model, Millikan, who developed an oil drop experiment that specifically looks at the electron, and Rutherford, who looks at the nucleus and the proton, and finally Chadwick, who looks at the neutron. So we're going to take each of these scientists individually and look at what they contributed. So the first scientist we're going to look at is John Dalton, and John Dalton wrote a lot about atomic theory, but we only need to know 3 things that he wrote about, and that is that all matter is made up of small particles called atoms, that atoms are indivisible, as we've previously said, and atoms cannot be created or destroyed. So, over the next few slides, we're going to look at the discovery of the electron, and the scientists that are linked with that are Crookes, Thomson, and Millikan. So, let's start with Crookes. By 1830, a scientist called Michael Faraday had begun to study the effects of electric current on gases. However, it was in 1879 when William Crookes made the most significant discovery. Crookes passed electric current through air at low pressure in a vacuum tube, and he basically looked at what happened. So Crookes found that radiation of what we now know as electrons was coming from a plate that was connected to the negative end of a power supply. So this plate he called the cathode, and this is a good way to remember it: cathode negative, anode positive. The radiation of these electrons was shown when adding a high voltage current to the cathode. A shadow of a Maltese cross was formed. And the formation of the shadow showed that these rays, cathode rays, travelled in straight lines. So we can explain this very easily using a diagram. So as you can see up here, we have our cathode, and this is the cathode, and we have our anode, and our anode is in the shape of a Maltese cross. So a high voltage energy supply comes from the cathode, and the cathode rays travel down the tube and hit off the anode in the shape of the Maltese cross, and the anode is positive, so the cathode rays are attracted to it because they're negative. And Some of the cathode rays won't hit off the anode, they will pass straight through because the cathode rays travel in straight lines. And we know this because the cathode rays that hit off the anode in the shape of the Maltese cross, we can see down at the bottom of the tube that a shadow forms. And for the cathode rays that don't hit off the anode, they fluoresce the glass a green colour. And down here then is a diagram of what that would look like in real life. He called these cathode rays because they came from the cathode, and these rays were invisible. However, they do cause glass to glow a green colour. Another way of saying that is it causes the glass to fluoresce. So Crookes wanted to go further with his investigation of these cathode rays, and he wanted to look at the properties that they have. So what he done was he got a light paddle wheel and he mounted it on rails in front of the cathode, and basically he applied some electric current to the cathode, and this caused cathode rays to form. So these cathode rays moved from the cathode to the anode, as you would expect, and consequently caused the wheel to turn and move away from the cathode. So as I've said, the paddle wheel travelled down the tube away from the cathode. The wheel always turned away from the cathode, showing the movement came from cathode rays. So this slide is a good summary of what we've learned from Crookes. Crookes discovered cathode rays. He said they travelled in straight lines. They cause glass to fluoresce or glow a green colour, and they have enough energy to move a paddle wheel. So let's move on to our third scientist, and this is Thomson. And Thomson is still looking at the discovery of the electron. So in 1897, he decided to investigate if the cathode rays consisted of charged particles. So with this investigation, Thomson obtained cathode rays by passing them through a small hole in an anode, because we know that the cathode rays will travel from the cathode to the anode. This beam of cathode rays was then passed through two parallel metal plates onto a fluorescent screen, and when the plates were uncharged, the beams travelled in a straight line down the tube to one specific spot. However, putting a positive charge on the top plate made the spot or the rays move upwards. This showed cathode rays consisted of negatively charged particles, and this is because the positive plate, when the plate was positive, it caused the rays to move up, and we know that opposites attract. So if the rays move up, they must be negative to be attracted towards the positive. So Thomson called these electrons, and this was actually first proposed by an Irish scientist called Stoney. So this diagram helps explain it here. As you can see, you've got the cathode and we've got our anode. So the cathode rays were passed through this little hole here and here, and basically formed our straight line along there when the two plates, which are here, were uncharged. Now, when a positive charge was placed on the top plate, it caused this black line to form and caused the cathode rays to move upwards along the edge of the glass. So this meant that the cathode rays were attracted to this positive, meaning that they must be negative in charge. Consequently, from this experiment, Thomson was also able to calculate the ratio of the charge of the electron to its mass, and this is called the EM ratio. So, now that Thomson discovered that cathode rays had a charge, people wanted to go and measure this charge, and this was done by Millikan. So Robert Millikan used an oil drop experiment to measure the size of the charge of an electron. So what Millikan done was he sprayed tiny drops of oil between two charged metal plates, and he used X-rays to ionize the air, meaning that it lost electrons. The oil that has been put through the two charged metal plates picked up the electrons from the air and became negatively charged. He then used a microscope to focus on one specific droplet of oil, and when he applied a positive charge to the top plate, the drop that he was focusing on rose upwards. He then adjusted the charge until the drop became stationary again, and he measured that the charge on an electron is 1.6 by 10 to the minus 19 coulombs. So let's explain this using a diagram. So as we can see, the oil is sprayed in, and you can see that it drops down in here. So these are your two charged metal plates. As you can see, there is wires going into them to show that they're going to have electric charge. So when a positive charge is placed on this top plate, this oil drop moves upwards. And basically the charge is changed until this electron becomes stationary. And when this electron becomes stationary, Millikan was able to see the electron through the microscope and from there determine the charge of the electron. So that's all we're going to look at for the discovery of the electron. We're going to briefly come back to Thomson, as he developed a model called the plum pudding model. And for the plum pudding model, Thomson said that the atom is a sphere of positive charge with negative electrons embedded. So this is the model of the atom that Thomson came up with as a result of all the discoveries made based on the electron from the first four scientists that we've already looked at. So let's look at the discovery of the nucleus. The main scientist involved was gold foil. And what he found was the majority of the alpha particles passed directly through the gold foil. He found that some of the alpha particles were deflected at angles, and then he found that some of the alpha particles were reflected back along their own path. These results were very unexpected and did not follow the idea of Thomson's plum pudding model. He believed that the mass of the gold atoms in the gold foil were concentrated in a small, dense area, and he called this the nucleus. And we can see that this is the nucleus that I've highlighted there, it's in red. So basically, some of the alpha particles travelled straight through the atom. Some of them were deflected at angles because they came in close contact with the nucleus, and the others were reflected back along their own path due to coming in direct contact with the nucleus. So this slide summarises Rutherford's experiment, where most of the alpha particles pass straight through the gold foil, and this is because the atom is mostly made up of empty space. Some alpha particles were deflected at large angles, and this is because they were repelled when they pass near the nucleus, and the word repelled is very important there. A small number of the alpha particles were reflected back along their own paths because they collided head-on with the nucleus, and again, colliding head-on is very important in that point. Rutherford is also linked with the discovery of the proton. So as well as bombarding gold foil with alpha particles, Rutherford also bombarded other substances. And basically, he found in the case of small or light atoms, such as oxygen and nitrogen, that small positive particles were given off. This did not occur with heavy atoms, and this was explained by saying that the alpha particles were breaking up the nuclei of the lighter atoms, but this didn't occur for heavier ones because of the large positive charge that would be experienced from the nucleus. And he called these positive particles protons. So the last thing we need to look at is the discovery of the neutron, and the neutron was discovered by James Chadwick. Like Rutherford, he bombarded substances with alpha particles, and he specifically bombarded beryllium with alpha particles. He discovered that when he bombarded the beryllium with alpha particles, the type of radiation that was given out contained no charge. These were very difficult to detect. but he found that they had enough penetrating power to pass through paraffin wax, and when they did, protons were knocked out. He found that the protons and the neutrons had similar mass but a different charge, so the neutral particles, he called them neutrons. So this next few slides goes through the subatomic particles and their properties. We know that protons and neutrons are stored in the nucleus, and this is thanks to Rutherford and Chadwick. We know that protons have a positive charge and neutrons have no charge. So electrons move around the nucleus in shells, and we know this from the discoveries of Thomson, Rutherford and Millikan. And we also know that electrons have a negative charge. So this is a summary table that you should know from junior cycle about the charge, mass and location of the different subatomic particles. So that's it for today's video. Make sure to revisit the learning intentions